Yes, class. We started with diffraction. So let us quickly complete this topic. One last topic is hanging in your syllabus. So see types of diffraction. There are two types of diffraction which are present in your system. One is the Fresnel's diffraction. This is inversely proportional to the separation. And one is Fraunhofer's diffraction. Fresnel diffraction basically says that wavelength is inversely proportional to the separation between source slit, which is finite. Here we take the separation to be infinite. Fraunhofer's diffraction. So you have in your syllabus Fraunhofer's diffraction included. This is basically Fraunhofer's. This is Fraunhofer's diffraction. Two types of diffraction, Fresnel's diffraction, Fraunhofer's diffraction. Now in your syllabus, you do not have Fresnel's diffraction as a part of it. Just the difference between Fresnel's diffraction and Fraunhofer's diffraction was that separation between the screen, the source and the screen, that was finite. All right, that was Fresnel's diffraction. And separation between the source and the slit is infinite in case of Fraunhofer's diffraction. Now see, understand the figure first, then the derivation is very easy and quick. This is a lens that is taken. These are the slit. Why lens has been taken? So that the refraction can occur and the diffusion does not occur. That is, the light rays do not spread in their original directions. You have all the light rays converging at a point. Now this light ray is going. Here is an obstacle, that is the slit. It bends. And another refractive bigger lens is kept so that whatever rays are coming, it converges it again to a one point. Similarly, this ray came, this got this bent, and again at this point. Similarly, from this point, this ray came, it bent and converged at this point. All right, and these are also the straight rays which are converging and giving you the central maxima. Here, this is the central maxima that has been obtained. This angle is taken theta, and from here a perpendicular separation is being kept, which is just for the construction purposes. This is not a part of your derivation. For the derivation, it's not helpful. You just have to remember this is the slit width, that is A. This is the separation between the screen and the slit, that is capital D. This is the angle theta n. This angle is also theta n. Now, starting with the derivation. This figure is clear to all of you. This is how you have to write it. See, when we are talking about the path difference, just a second. Okay, so the path difference. C class, if we take this triangle, C, D, N, this triangle if we take, and this angle is theta, which I'm taking. So it will be DN divided by CD. So in triangle CDN, sine theta is equal to DN divided by CD. So dn is equal to a sine theta. Okay. From here, if we calculate tan theta, that will be yn divided by d. How? See, this is your theta, tan theta. If you calculate tan theta in this triangle, I'm calculating. So tan theta will be, this is yn, that is the separation of central maxima from the point of calculation, and this is d. So perpendicular by base, that gives us tan theta, which is equal to yn divided by d. So from here, yn is equal to d tan theta n. And see, tan theta can almost be written as theta. In small angle derivation, this can almost be written as theta. All right. So y is equal to d theta n. Now come to conditions of secondary maximum. The conditions of nth secondary maxima, firstly, for minima. For minima, we always take the path difference here to be n lambda. So a sine theta n here will be equal to n lambda. All right. So, and n is what? N is 1, 2, 3, and so on. So what is theta? N lambda divided by a. This is the angular separation which we were calculating. This was theta n. So this is angular separation. Yn is equal to theta n into d. So yn, theta n is n lambda small a here multiplied to d. This is the linear separation. This is the linear separation. All right. So these are the conditions for minima. Clear, class? Now, one more thing, we have the conditions for maxima. So that let me discuss conditions for nth maximum. So for maxima, what you have to do? For maxima, you have to write the path difference first. See, now the formula is different. Instead of minus, it is plus 1. 2n plus 1 lambda by 2. A sine theta n is equal to 2n plus 1 lambda by 2. So sine theta n is equal to 2n plus 1 lambda by 2a. This a will come here. Again, this will be, see, theta nth will be 2n plus 1. Remember, class, it's plus in case of diffraction. It was minus in case of interference, divided by 2a. So this entire is the angular separation. Same thing is being repeated. You just have to remember the main condition first. All right. And one more thing, the linear separation. Again, if we talk about the linear separation, that is theta n into d. So linear separation will be 2n plus 1 lambda capital D by 2a. This is the linear separation. This is the linear separation. Write it down. A parallel beam of light of 600 nanometer falls on a narrow slit and resulting diffraction pattern is observed on screen 1.2 meters away. It is observed that first minimum is at a distance of 3 millimeters from center of screen. You have to calculate the slit width. So first is theta n is n lambda by a, which is equal to lambda by a, because this is the first minimum, so n will be equal to 1. Lambda is 600 nanometers, so 6 into 10 to the power minus 7. Slit width, how much it's given? Okay, slit width we have to calculate a. This is given as 3 millimeters, right? Is at a distance of 3 millimeters from the center of a screen. You have to calculate slit, right? This we have to find out. So see, firstly to find out, this will be 3 into 10 to the power minus 3. All right. Secondly, parallel beam. See, for this we have to calculate. Slit width we have to calculate. This is given at a distance. Now see, this says that first minimum, calculate the slit width. So you just have to, you have the value of lambda is 600 nanometers. Capital D is 1.2 meters. Small d is 3 millimeters. See, every value is given for slit width. Theta, see, A, this formula we'll be using. For the slit width, we'll be just using y is equal to theta by d. Dn is equal to a sine theta. So from here you have a sine theta is equal to lambda. Theta is equal to n lambda by a, right? So yn is equal to n lambda d by a. So y is equal to n lambda d by capital D by a. This we have to find out. The rest of the things are already mentioned. N lambda capital D by y we'll just keep. All right, because this is 1.2 given, this is 3 millimeter given, this is 600 given, and this is the first minimum is already mentioned. So we know the formula for minimum. We have written a condition for minimum. This is the condition for minimum. All right, for minima condition, we always write it as n lambda. So directly you just write it as n lambda. All right, just write down this quickly. One more question I have to solve. These values you can solve it later. You will be able to calculate. One good question which involves all the parts that I'll discuss with you. First, write this down. This question, class. This is an important question. This will cover most of the portion. Yes, so this says in single slit experiment, light of wavelength 6000 angstrom is used. Slit width is 2 millimeters. Separation of slit is from screen is 2 meters. You have to calculate the separation of first minima from central maxima, angular and linear, and separation of central maxima. So usage of minima and maxima is very clear through this question. Wavelength is 6000 angstrom. Wavelength is 6000 angstrom, that is 6 into 10 to the power minus 7 meters. Slit width is given as 2 millimeters, which is 2 into 10 to the power minus 3 meters. So first one, angular fringe width, a slit width. When we are calculating the angular separation, this is n lambda divided by a, which is equal to lambda by a. Because n is given here as, again here also n is equal to 1 in the first part. So lambda is 6 into 10 to the power minus 7. A is 2 into 10 to the power minus 3, which is equal to 3 into 10 to the power minus 4 radians. All right. Okay, angular and linear both. So see, for linear I've told you this is theta n multiplied by d. Theta n we have calculated 3 into 10 to the power minus 4, and d, that is separation between the source and the screen. This is 2 meters. This is 6 into 10 to the power minus 4 meters. Second part, theta n is equal to 2n plus 1 lambda by 2a. Here n is equal to 2. So if we put 2, this is 4 plus 1, 5 lambda by 2a. This is 5 into 6 into 10 to the power minus 7 by 2, and a is 2 into 10 to the power minus 3. So this you can also solve later and figure it out. When we have to calculate the linear separation, this will be theta n into d. So 5 into 6 into 10 to the power minus 7 by 2 into 2 into 10 to the power minus 3 multiplied to the separation d. D was how much? 2. So this will be 2. This you can solve. Let me know what's the answer. Write down the solution. Now small topics are only left from diffraction. Major portion of diffraction was this only. Let's see the width of central maxima and all. Okay, class. Now, this is the central maxima which has been formed. This is the source. Source is producing the diffracting waves. See, did you notice in interference, here were the light rays which were coming and they were converging at a point. Here they are diverging also. Reason behind this is that because the bending of light rays is occurring from the edges. So these are diverging. So this is theta 1, this is theta 2, which we have discussed in detail also when we were discussing the derivation for it. So from the center, this is y1, this is y2, the way we take it as d by 2, d by 2 in case of interference. So here you will get the first minima, then first maxima, second minima, like this, the way we had bright fringes and dark fringes. Here you have the same concept of minima and maxima. Now talking about the angular width of central maxima. This is double of theta because angular width means this is the angular width. So 2 theta means 2 lambda by because one single theta meant lambda by. Linear width of central maxima, if we calculate this will be, see, linear width whenever we are calculating, if we have arc also, what we do, we multiply the separation, that is length, with the angle we get. Understand? Separation, the way you have the formula, no, length of arc is equal to radius of arc is equal to theta, L by theta. So same. So this is angular width multiplied by the separation. So that is 2 lambda capital D by. Write it down. These formula also you have to remember. Now only basics are left. Now see, we had seen the intensity distribution curve for interference. This is the intensity distribution curve for diffraction. So it's very easy. It's this intensity distribution curve is easier than the interference one. You know path difference is n lambda. For first it will be lambda, second it will be 2 lambda, 3 lambda, 4 lambda for minima. For maxima, all the odd numbers will come because of this plus 1. So 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, 9 lambda by 2, like this. So when we plot the intensity versus time graph, intensity graph versus the displacement that is occurring, these are all the values that we have taken. Intensity gradually diminishes. Diminishes, it decreases, and it finally becomes 0. So remember, intensity of central maxima is more, then it decreases, irrespective of whatever is present, whether it's minima or maxima. A very important question that comes is differentiate between both the intensity distribution curve for interference and diffraction. So you have to be very sure that their intensity remained constant for I for coherent sources and independent for non-coherent sources because of the variable. Okay. Then here you have to show that the intensity is gradually diminishing. And these are some experimental values, which if you would remember, your answer would look very great. That is, firstly, it decreases by 21 times. It decreases by 1 by 21. So I by 21, then I by 61. Other data, even I don't remember. You also don't need to remember. Nobody is going to ask you even. But if you mention these will enhance your answers like this. So these are all the values here. Like this, intensity decreasing and is decreasing. So we obtain a bell-shaped curve. Often this is said to be bell-shaped curve. Write it down, then we'll see the points of differences between interference and diffraction. So these are the points of differences between interference and diffraction. Last topic. So interference, this is superposition of light waves from two coherent sources, and diffraction is superposition of secondary wavelets from the same wavefront. We had seen, no, because of the lenses, the superposition of waves were occurring. Then bright fringes maxima have same intensity. This we have seen through the graph properly. And intensity of maxima decreases. Then all the fringes have the same width. Here, fringes can have different widths. There's a good contrast between bright and dark fringes. Here, minima and maxima have a poor contrast, meaning that you will be able to identify bright fringes properly on the dark background. Like black and white, the way we identify black and white. White is very prominent, black is very dark, like this. There's a poor contrast. That means when you see the diffraction experiments, hazy portions will be there. Somewhere you'll be able to identify maximum minima, somewhere you won't be able to identify. All right, write down this as well in a tabular form because this question comes. And here, one more thing I'll suggest that if time permits, draw the intensity distribution curve for both of these. Also, one more thing you can add, that interference through Young's double slit experiment occurs through two slits, and in diffraction, one slit solves the purpose. All right, class. So this completes with the syllabus. Now you'll be getting the proper revision schedule. We'll be starting with the revision on Saturday only. From Saturday, tomorrow you have an off, so you people will not be joining classes tomorrow. So we'll be meeting now with the revision schedule. Schedule will be given to you earlier only. This week only you will get properly. We'll start with modern physics only because questions practicing we couldn't do very well with modern physics because of this rush of completion of syllabus. So at least now syllabus is completed. Once we have completed everything, modern physics I'll start. Dual nature, atoms, nuclei, revise this whole week. I'll start with that only. Okay, class. So you will be allotted the timings. Any doubts you have, I am there. You can arrange an extra class with me. All right. Whichever doubts you have, you can click a picture, send me on WhatsApp also, get your doubts clarified, whichever portion you're studying. I am always there. You can contact the team also. Let me know if you have any doubt, any query. If you want a particular topic to be repeated, that also you can know. All those students who joined late the sessions, I think Amna and all these Sidra, you people have joined late. Some chapters have also been missed by you all. So do not worry about that because in revision classes, we will not be just going through the numericals. In revision classes, you all have to study by yourself also. I'll be asking questions also. It has to be interactive. These days, I wasn't very much asking you people questions in between because you people will not be answering and then time takes to unmute yourself, get you all back to the classes, and syllabus had to be completed. That's why I was leaving you. But now in revision classes, attend all those because all the previous year questions, important numericals will be covered. So it would be a very good revision for you. So if you attend the revision classes, after that you study your syllabus, you will find it very easy and you will get lots of questions practicing also through this only. So I'll be asking also, you have to be prepared for the revision classes, and there we'll be revising the theory part as well. So all those students who have missed on their classes, missed on their lessons, I am there. We'll be able to complete it. But even if you want any basics portion which you're thinking you are not able to complete, like your differentiation, integration, vectors, very basic topic, text personally, I am there. Group is there. On the group you can send questions. On the group you will be updated. Through the group you can text anything. All right. Also, if you have any query right now also, you can let me know. My WhatsApp number, I hope, is with all of you. You can text, get your doubts clarified. I think in this batch only Tarif has this habit of this doubt session clarification. Revision class is Saturday, next Saturday. Fadil, next Saturday. And now you won't have to join these double classes. If the revision class is 1.5 hours or 2 hours, whatever it will be the duration, it would depend upon the chapter also, 1.5 hour minimum, but only that much only you have to join. Like you all, especially this batch students like Amna, Deborah, Sidra, Fadil, you people had to attend double classes. And recently, since wave the Tharif and all, you also had to attend the classes of the evening one. So now that part I am cancelling because that was there for the syllabus. You should get time for self study also. We'll be having classes. The revision time is enough for 1.5 hours, 2 hours. But join that according to your allotted time. You will be allotted different time. So that will be discussed, and I think by Wednesday you will get it. Wednesday or Thursday you'll have this schedule with you, and that I'll discuss and let you know. There is a lot of time firstly, but this I'm telling you, modern physics will start, so please revise. It will be very helpful if you do your revision because I'll be asking. Okay, cameras will be open. Be prepared for it. With open camera, you all have to study, revise properly for 1.5 hour, 2 hours sincerely. Then you can leave, continue your self-study sessions, continue your whichever way you want to study. Send me your pre-boards papers on WhatsApp so that I am also updated with what you all are going through in your schools. What type of questions are still coming in your pre-board so that in the revision classes I can add on. All right, class. It was lovely with all of you. Next Saturday, we'll start with the revision classes. Till then, okay. Thank you so much, class. Take care. Study well. Update me. All right. Thank you so much. You all can leave.